right, well, I just got a telemarketing call. Interrupted that video. The big asteroids, I mean, they're like, I don't know, half of California, I mean, something floating out there in space, so, yeah, that would be a bad day. It'd be bad to be hit by something 6 miles wide. It'd be bad to be hit by something half a football field wide. So we'll talk about that. So a lot of smaller ones and a handful of bigger ones. Comets, however, I said 1 to 10 miles, I think a half a mile, whatever, something like that. So on the order like an iceberg, right? 1 to 10 miles across. Lots of small ones out there too, chunks of ice, I suppose. And meteoroids are space debris, and they're just whatever, right? It's just whatever size they are, little grains or chunks, whatever they are. So that's a nice overview, I think, of these. The asteroids in the asteroid belt, they kind of a wannabe planet. If you swept them up, it wouldn't be a very big planet. I don't know, maybe our moon, before it hit us, maybe it was over there in the asteroid belt. Maybe Jupiter messed with it with its big old gravity and tugged it off, and then it went in and slammed us. Maybe our moon was going to sweep up its room and become, a big planet out there. But Jupiter pulls on those asteroids in the asteroid belt, and they can't get it together. What are you going to do? Right? A notable mission. So I do want to say just that when Galileo mission went to Jupiter, it flew by Jasper and Ida, and it found that Ida had a little moon going around it. So everything's got gravity, not very much. Near landed, so the mission 2001 landed on Eros. So we study this. Why? Because, as I said, they haven't changed much, and so there's a lot of information, and it validates also the age of our solar system, okay? And gives us the age of our solar system too. And 2005 deep impact. So what you do is you send a part of the craft into the comet, make it hit, send up a plume, the other part flies by, so you kind of, let's kick it up and then fly by it and then analyze it. And so that's kind of cool. And so yeah, we've studied this stuff, and it's interesting. Crunch time. Let's talk about some collisions, and then we'll talk some more. I'm going to show you some pictures. I've got a list of things, and I say here, what can happen if something hits us? Well, you might spark life because create amino acids out of organic carbon-based molecules. Maybe a comet will bring in some water. How about if we take all the comets and put them onto Venus? That'd be kind of cool. Or Mars. Why not both? Try it. See what's going to happen. But it's easy to do on a video game, but how are you going to move an iceberg? How are you going to move 100 icebergs? Could cause extinction and devastation. We'll talk about that. And it creates a cool spectacle. So that's interesting. And I talk about these. I will maybe I'll give you a quick tour here as we're looking at this real briefly. I don't expect people to memorize this, but it's interesting. Like 66 million years ago in the Yucatan, I'll show you and talk about that a little bit. The Meteor crater or Barrington crater in Arizona, 50,000 years ago. 1908, Siberia, show you a picture about that. Comet Shoemaker-Levy. And maybe we'll come back to these guys too a little bit. Well, I'll just say a chunk flew over the Sudan, and it tends to, when it goes through our atmosphere, it heats up and breaks up, and you had all these little nano diamonds or microscopic diamonds, and diamonds are like carbon in the right temperature, pressure, etc. Diamonds, that's pretty cool that you would have that. So 13-foot diameter asteroid exploded above the desert, 23 miles up. Oh, what layer is that? 23 miles up. Stratosphere. Reno, 2012. The size of like a minivan came through and then broke up into pieces. And you know, you go out and find that stuff. It's valuable and it's interesting. You can't just dig up a rock because you can analyze it. And in Russia, 2013, you got to look at that up. I'll show it to you. So I'll show you, and that's kind of cool. So there's some neat things. Yes, we have had collisions, some of them creating very deep impacts. And let's look at some pictures for that. Okay. Let's go back over here. There we are. Let me pull up some pictures for you. There they are. All right. So you can have some fun. You know, you can't memorize it all, but you get a sense. Remember Gaspra and Ida, Galileo flying by that on its way to Jupiter, and Eros, and, you know. Hey, look at that Ceres. Is that a planet? Well, you know, should Pluto be a planet? There's some big chunks out there. Streakers. You can actually see them with the telescope if you know where and you know, tune into how to find them. It's kind of cool. They're out there. Various sizes. Okay, let's go with this. Siberia, 1908. So this thing comes in through our atmosphere, heats up, and torches the forest, thought to not have hit because you don't see this big depression, but it torched the forest. There's a major barbecue here if you like squirrel and stuff, you know. So it just, good thing there wasn't any city, but nice thing about Earth is it's mostly unpopulated, so, you know, you kind of play the odds. Doesn't mean you're not going to get hit, but it torched. And I'll show you this too. I think that was the first year that the Chicago Cubs won the World Series. So there's a lot of, you know, there's a lot of area there. And so it came in and was thought not to hit, but then in, what year was that, 2007, I want to say? Yeah, I think so. There's kind of this article about, hey, it looks like maybe it did hit. It just hit over there, and it created this depression. So you can follow up on that. 1908, and maybe that created that, and then you filled it in with the water. Stuff happens, but not very populated then. Let's talk about the Dinosaur Killer, asteroid crater. Okay, in the Yucatan. Look, there it is. Remember chapter 5? Who got hit more, Earth or Moon? Who's the bigger target? Why don't we see Earth covered with craters? Because we cover them up. Tectonics, erosion, right? So here's a big crater, which we can image. And you can use dating methods, not just guess, but you can use dating methods. And the cool thing about this is, this thing hit when the dinosaurs went extinct. This thing hit. And a thought, you might look up the father and son physicist, geologist duo, look at Berkeley, et cetera, you know, thinking about this, and you go, well, where's your evidence? Come on, where's your evidence? Aha. There's a type of atom called iridium. You find it more in the asteroids. You find it more out there than you do here. And yet, if you go around the globe, at the time the dinosaurs went extinct, you have a layer of iridium, as if brought by something, creating this incredible plume that traveled through our atmosphere and laid down a layer of iridium. Talk about a smoking gun. That's pretty good evidence that as that went up, and if you've ever seen some of the fires that we've experienced in California, et cetera, man, that can haze can really block that sun, kill off plants, right? And those animals that need to eat a lot die off. Those reptiles that, by the way, were eating those little mammals for snacks, maybe getting rid of the reptiles allow those little mammals to evolve. Interesting, right? And so we think about life and all that. There's an image of it. People are diving down there to explore it now. So, yeah, what about that? Well, we saw it. Siberia got hit in 1908. This is Russia, what, 2013? You see this. Talk about fireball. So when we'll talk about that in a minute. You see this happen. Wow. What is that? I mean, something the size of half a football field could take out a city. Right? That plume, the energy, the heat in the air, etc. So, yeah, and when they hit, approximately the size of the thing, well, 10 times that is kind of where the impact crater might be. Right. So, it could be a bad day. If it doesn't hit your city, it's just kind of cool. So what happened here? This is the best thing, though. Oops. I'm going to go back. And let's get out of this. And let me show you this. And I'll go up here, or I will go here and bring up, here we go, this guy. Injured by falling glass. As the thing goes through our atmosphere, heats up, breaks up, might not make it, did make it, not in town. And when this happened, those of us that were watching this and watching it going, why? How come you have so many images? And why are all these people taking video in their car? Well, it turns out that in Russia, and it's very smart, you're required to have a dash cam for insurance purposes. I mean, that's great. Now you know who hit whom, right? So this is pretty wild. Man, that would be freaky. And this wasn't detected coming in. Now we've seen ones coming in, or coming around, and we have to see, are they going to hit Earth or be in a certain path? And there was one that if it went through this one region, then it would come back in like 2036 and we'd be in trouble. It doesn't look like we're in trouble. It looks like we're okay. And we really haven't been detecting this. I would say late 90s, really been earnestly looking and keeping track and watching this. So why do we do astronomy? Maybe to save us. Right? Maybe to save us. There's a lot of reasons. What will we do? Well, maybe if it's coming towards us, maybe we'll try to slow it down so it misses us, speed it up so it misses us. We probably don't want to break it up and then get a whole bunch of things, right? And then that's really hard. So there are ideas, people are evolving, and you can bet we'll all put our efforts towards redirecting that thing. How big was the thing that wiped out the dinosaurs? So piecing the evidence together, I think from what I know and recall is about 6 miles. A 6 mile wide, well, that's not that big, right? A 6 mile wide chunk hitting Earth, wiped out the dinosaurs. That seems to be what the evidence says. So, asteroids hitting, comets hitting, and so on. All right, let's get this out of here. Bring this guy back in the picture. Various chunks. Now, various chunks can hit Earth, right? Here's a fragment from Vesta. You saw a picture of Vesta, right? Something hit Vesta. So they can have different combinations, right? And we called them meteoroids, but this is called a meteorite. What's the difference between a meteorite and a meteorite? Oh, this is actually been spelled incorrectly, but at least American spelling, I don't know. Now, you know, are you going to buy that? I don't know. Is that just out of you have to analyze it. You got to look at the chemistry or whatever. And people can, so you take it to a science book. You don't take it to someone just casually. But it can be very valuable for science and for astronomy to study this, and interesting and all that stuff. So different stuff, different compositions, chondrites. So what you do is you take a chunk. I'm going to show you a chunk. Take a look at that right there. Watch in a minute. But if you take a chunk and you slice it and you etch it, what you see is this. And this is iron. Well, iron, when it crystallizes and forms on Earth, it's a different environment than forming out there. And so you can tell this thing formed in space by looking at its structure. So you can look at its structure. So you can analyze this. It's chemistry, geology, you know, all that stuff put together. Bad day maybe, I don't know, I heard a story that the person got more for the car than the thing, but, and I'm gonna let you look up. How many people have actually been hit by an asteroid? Anybody get killed by an asteroid? You look that up. It's really easy now, you can just look that up. But the odds are you won't be, because even if something comes through, I keep waiting for something to come through the roof. You know, just the odds are that you aren't going to get hit. Doesn't mean you won't. Some people got hit by lightning twice, right? So, but I wouldn't worry about it or lose sleep over it. I don't worry about it, and I don't lose sleep over it, but here it is. Now here's a comet hitting Jupiter. I mean, we haven't had technology like this for very long, right? So we haven't had great technology to be able to watch this stuff happen. And we did, however, look at this, and a guy named Shoemaker and a guy named Levy spotted this thing, and this comet coming in. It's going towards Jupiter. All the stuff we've learned comes into play when we think about this now, because why is there a stronger pull on the near side than the far side? It's the tidal effect, because gravity gets weaker with distance, so it's pulls stronger, closer. And what does that do to an iceberg? Rips it apart into pieces, doesn't it? And what happens when it hits Jupiter? Does it make a crater? No, right? You're not looking at a solid surface. You're looking at gas, so it goes poof, 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 poof. Pretty cool. Pretty cool. And since that happened, when we could image it, we got to see it. And that's fun. So collisions happen. Thankfully, they don't happen as much. Thankfully, it's not as messy out there. There's the comet broken into pieces. And look at that. I love this picture as we close down on this semester and get closer. We're developing this context, this sense of stuff that's so big, and even atoms so small, that is beyond our human senses, and yet we've been able to figure it out. And I love this picture because when I think of a star, right? A star now we know is light years away. Even the closest one, 4 light years away. That means light takes 4 years. It's incredibly far. Spacecraft, tens of thousands of years to get there unless we figure something out. But these stars are in our galaxy, right? The stars that you see are the close ones and the luminous ones in our galaxy. That's what we're seeing. Very far away. And then you might see a dot that if you watch it week to week, changes its position. AU's away. That's in our hood, right? That's in our solar system. And you might see a streak. And someone said, look, a shooting star. And you say, a shooting star? Is that a star? Is that far away? Is it close? Is it light years? Is it AUs? Or is it miles? Remember, something at a distance looks like it travels very slowly, doesn't it? Something very far at a distance, even though it could be traveling very rapidly, you can't even tell it's moving. Is that a shooting star? What is that? What do we call that? Orionids. Streaks. Why is it that we know the day of the year that we'll be able to see the Orionids? Seeming to come from Orion, but not quite literally, and it's not quite that easy, but they're called the Orionids because they seem to come from Orion. And, well, you can imagine, these are called the Leonids. They seem to come from Leo. Good meteor shower there. The Perseids, the best one. Why do we know when we have certain meteor showers? I don't know. You might have to wait until the next video. We'll see if I chop this one up a little bit. But let's take a look over here. Let's take a look. So, we kind of talked about asteroids. That's good enough. We're going to come back to comets. They play a role here. Meteoroids. It's really easy, actually, to tell the difference between these words. Meteoroid, meteor, meteorite. If you use that DRT, it's like dirt, but not soil, because that's organic, right? So, DRT is in alphabetic order. DRT is spatially where they are. So if you have a chunk that's out there beyond our atmosphere, which you know is only a couple hundred miles, right? It doesn't have to be very far. It's called a meteoroid, just like an asteroid we hope stays out there, right? Roid in the void, out in space. Meteoroid, 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 meteoroids, whatever. But if it comes through our atmosphere and creates those streaks, we call it a meteor. A shooting star? Is it really a star? Is it really a star? I mean, if the softball sun is our sun and we're a grain of sand, what if that streaks through our atmosphere? I don't think we're going to get that close. Is it really a star? No. What could it be? Well, some of the stuff burns up, and we'll talk about what those annual meteor showers are. But some of it hits the ground. And the stuff that hits the ground is called a meteorite. Think hit, ite, ouch. Meteorite, meteoroid out there. The same piece, while it was out there as a meteoroid, now it's a meteor going through, this will make a fireball. It chars up, right? It chars up. It'll make what we call a fireball. It's really cool. You just happen to see it. It happens. Happens a lot. Like a car's worth of stuff hitting Earth every day. But if it's daytime, you're not going to see the streak. And if it's over the ocean or Siberia, you're not going to be able to see it streak. So it happens a lot, though. It happens constantly. Often burns up, but it might hit. And then you say, "Ite! It hit me." Or did it? Hit me. Meteoroid, meteor, meteorite. It's that simple. That's what they are. But why is it that we have meteor showers every year? And we know you can make a list, as you did. Why do we know that on that day we're going to see streaks in the sky? Comets. Comets. Now, was I out of the picture a lot there? Did you see this? Did you get to see that? Oh, did you get to see that? Bring it up close. That little chunk there. Chunk of iron. How do I know I didn't pay money for something someone dug up in their backyard? Well, I'd have to cut it and etch it and see if I see that pattern, right? So, the mystery. All righty. So, let's talk now about comets. Shall we? Where am I? There I am. Okay. Here's a picture. And here's a challenge for you. From this picture, if you don't know, you'd probably guess wrong. The two questions I have are, where is sun, and what direction is that comet traveling? Now, comets often have two tails. They often have two tails. And those two tails will answer those two questions, but not in the way you might think. Most people guess it wrong, understandably. Why? Because the word comet is related to the Greek word for hair, like comb. A comet. Long-haired. A comet. A long-haired what? Star. What do you mean, star? A little twinkle of light. That's what a star was. It was a twinkle of light. They call Venus the morning and evening star. Well, it's a twinkle of light. That was reasonable back then. Now we say, no, it's a planet. Shooting star? No, not a shooting star. It's something going through our atmosphere, just often burning up in the mesosphere with 30, 50 miles up there, whatever. But could go through, right? Could go through. Comets out there. What is that? Oh yeah, that's that iceberg, right? Dusty iceberg that's maybe a mile or 10 miles across. Maybe it can bring water. It's made of water. Water. That's so cool. So could it be? Could it be? I'll let you look at this. There's some different ways we can get water. And it's being explored, making some progress. But am I drinking comet juice? That's good comet juice. Good comet juice. I don't even know if I'm in that picture. But yeah, drinking comet juice. Okay, cool, whatever. Contra Costa College here, our mascot's the Comets. Contra Costa College Comets. Code. So there we go. What direction, where's sun and what direction is it moving? let's take a look. So there's these different parts for this long-haired star, comet, cone. The nucleus is the object. That's the iceberg. The coma is like a cloud, and it gets very large. And then often there's two tails. Now they can look different, but this is the basic idea of what makes a comet. But how do I know which way it's going? How do I know which way it's going? Let's take a look. I put this up here because it's wrong. Okay, long-haired, but comet. If you have long hair and you run this way, then your hair goes back that way, right? It's like, but that's not true with the comet. That's not why you might think it's going this way, so the cloud is streaming off of it. Except there's nothing to push it off of, right? You're out there in space where there isn't an atmosphere. So that's not what it is. Let's take a look at what that is, and let's draw it over here and solve that puzzle. So what I've drawn is an iceberg orbiting the sun, a very elliptical orbit in this case. Some of them stay way out there in the Kuiper belt, and then some of them are kind of the kicked out comets of the Oort cloud, which we still have lots of questions, don't really know what's out there. We know it's cold, so not expected to find trees out there or something like that. But let's do this, and you'll learn some, I think, cool things along the way. I listed a bunch of comets there, and there you go, and we're done. All right, cool. Let's talk about comets and finish this off. Leftovers. Now you got a taste of leftovers. You see what's up with them. And I vary some other, actually, just send us 9 pizzas and Coke. I'm going to take you back over there for a little bit. So I've got a comet. And it's some iceberg. And around it, there's like this cloud that reflects the sunlight, so it looks really big. And there's often two tails. One's kind of a bluish one, one's kind of a yellowish one, but whatever. And one's straight, often, but again, when you look at the pictures, not necessarily as clean. Long-haired star, comet. Didn't know what it was. Bad luck. Bad luck. It's got to be bad luck. So what's really going on? Well, let's take a look. Let's put our sun in here. A star. A real star. Not this shooting star nonsense. A real star. Let's put Earth in here too, by the way. I'm going to throw Earth right here. I'm going to make its orbit. You know it's very close to a circular orbit, really. It's elliptical, but very close to a circle. There's the orbit of Earth. I'd like to make our comet, I don't know, what color should I make our comet? Dusty, so black. And here's our comet. The nucleus, the coma, the two tails, right? And here it is orbiting. And that's its orbit. Now, what happens to ice when you bring it near the fire? Melts and evaporates, right? So you're coming in here, getting closer, and you got to get pretty close until you start melting and creating a little cloud. Don't you? You get closer, you melt more and evaporate more, right? And you get a bigger cloud. You melt more, and you get a bigger cloud. Big cloud, big coma, big coma, big coma. Now you go away, getting a smaller coma. And you're out here. But you've lost some, right? You've gotten smaller, haven't you? How much? Well, we'll see. What have I got here? Cloud, good. Something I was thinking. Oh, I know. I just wanted to show you the motion. So let's just do a little arrow for the velocity. This thing's moving this way, moving this way. So now what I'm doing is I'm showing you which way it's moving. Remember the two questions, which way is it moving, where's sun? Here's sun, that's where it's moving. Let's work backwards and find out where the tails would be. Ha! It's not hard, yay. Remember that sunlight and the solar wind? Sunlight and solar wind going out in all directions. And when it hits that cloud, it pushes it away. Right? It pushes it away. Really? How did I do that? Oh, fine. Pushes it away. So number one, first tail. Sunlight pushes it away, but it's not a big cloud, so it's not a big tail. Pushes it away. Pushes it. And now I know I'm moving that way, but the sunlight pushes it away. I'm exaggerating a little bit, but these things. It's moving this way, but the sun pushes it away. If I go backwards along the straight tail, no, that's not backwards. It's being pushed that way. Sun's got to be down here. Sun's got to be, oh, sun. Somewhere down there. Why? Because then it pushes it away. It pushes it away. It doesn't matter which way you're moving. It's not like hair. Sunlight is pushing it away. Pushing it away. Look, you're going that way still. It's pushing it away. It's pushing it away. Sunlight's pushing it away. Solar wind pushing it away. And some of that is called ions, ion tail, and then it's kind of dust with little bigger particles. And bigger particles have more mass. Oh yeah, mass, inertia. You know, those mass, you push it away and you keep going, and that the more massive stuff, I won't worry too much about that, but well, it drags behind. So it goes out, but some of the stuff, it lags behind. Let's go over here. A little one. This one lags behind. This one's going this way and it lags behind. It's pushed away, but the more massive stuff lags behind. So I'm going this way and it goes that way. I'm going this way and it lags behind. I'm going this way and it lags behind. I'm going this way, there's my tail, and it lags behind. So sun is here, pushes it away. This one's lagging behind. I got to be going this way. I mean, look how much that ties you into that you understand a lot. You understand what it is. You understand about how big it is, the nucleus, the coma, the two tails, tail of two city, Charles Dickens. So that's what they are. Is it bad luck? Well, could be if it hits, right? Could be good luck if it brings water. I don't know. Now, if they don't all cross our path, but if they do cross our path, here's another bonus round for you. Here's another plus for you. If I can find my blue pen, it'd be really nice. I have this tendency to put that somewhere. Okay. As it creates this coma, cloud, kind of leaves some stuff behind, doesn't it? The trail of comet dust out there. And there's not a lot of stuff. It's just it's not any air out there to blow it away, whatever. It's kind of floating, this comet dust, and less out here, right? Because it's not getting warmed up out there. It's simple enough, right? Oh, wait a minute. Here's Earth. Here's its orbit. 1 year. Whatever day of the year that is, right? It's always going to be there. Another year, same day of the year, we know leap year and all that stuff, but so on the day of the year that Earth passes through that patch of comet dust, that comet dust will streak through our atmosphere, giving our annual meteor shower. Some comets only pass through our path in one place, some pass through in 2 places. Some years will pass through kind of a thicker patch of comet dust and get a nice good shower, and other years not. August 12th, in that right there, go camping, go somewhere dark, get out there for the Perseids. That's the one you want to see. It's great. It's one more thing about how this is all tied together. The stars way out of our solar system, stars, light years, planets, AUs. Some stuff coming in, having hit. All the stories that people made because they didn't know, it's fine. Sunlight hitting Earth. Nighttime, daytime, as it spins, crossing the terminator, sunset, midnight, sunrise, right? Let's do that. Let's do that. You know, let's just say around 6 p.m., 12 midnight, 6 a.m. Why? Because we're spinning into the light. Sunrise, 12 noon. If we're going through a patch of comet dust, when's the best time to see it? Well, certainly not during the day, but also as we go through, it's going to be that part, that leading edge, that streaks through the most. Over here, it's going to go like this. So this part, always, wherever you are, that part's the leading part is going to go through it. 6 a.m. is not a good time to watch, though, right? Because the sky is too light. So when's the best time to watch a meteor shower? Whenever you want, when it's dark. Might you get something over here at 9 p.m.? Yeah, maybe. It depends. But the best time? midnight to 3 a.m. Why? Because you're streaking through that, coming through, and it's nice and dark, and you're on that leading edge. That's why it's the best time to watch a meteor shower. Just think of how many things you can share with your kids and your family and your friends and just yourself out there. So the leftovers are important and kind of cool, kind of dangerous. Maybe they bring life, maybe they take life. Perseids. They're just chunks. They grow as they get closer. That's a nice picture, right? Ooh, that's nice. Kuiper Belt, Oort cloud. Oort cloud goes way out. A lot we don't know about it. Here's a comet right here that we saw. I don't know if you can see it right there, but you know, it's cool. Piece it together. That's what we're doing now. We're starting to piece it together. And now we're going to go out to stars, but they're too far. We can't travel to them. We can travel to that one. We can travel to the sun. That's the one star that we can study, and we do. We've got some cool missions up there studying the heck out of it, right? Well, is it a big one? Is it a small one? Are they all the same size? Have they always been there? What happens? How do they get born? How do they die? Chapter 11. But before we do chapter 11, we've got to do chapter 10. You know why? Because everything we know about anything beyond our solar system comes from the light. Comes from taking the light in, making our little eyes bigger with telescopes, gathering the light, putting it together, getting clearer images and brighter images, using our technology, this gets better and better. Astronomy is nowhere without computer science now, right? So we put that all together and we gather more and more information. And we keep exploring and putting the puzzle pieces together. So that's what we're going to do. We're going to find that I focus on 5 laws of light. And we talk about the nature of light a bit. Light and matter. Atoms can reflect light. They can absorb light. They can glow light. And so we need to talk a little bit about light and the nature of light and those laws. A little bit about telescopes, because you got to grab the light, you got to break it down, sort it out, use the laws of light to give us some clues, and that tells you a bit about how we know about stars. Onward to chapter 10, and then chapter 11, which is very cool. Chapter 12, a very short chapter, brings us back to chapter 0 with the universe, cosmology, galaxies. Enjoy. Review.